Alright, welcome guys. Day 210 today. Let me double check. Programming everything until I graduate to get 210. So let's do the next problem on the list, which is number of connected components in a undirected graph. There is an undirected graph with n nodes. There's also an edges array where edges of I means that there is an edge between node A and node B in the graph. The nodes are numbered from 0 to n minus 1. Return the total number of connected components in that graph. Okay, so what does that mean? What does it mean to be connected, a connected component? So this means 0, 1, and 0 also goes to 2. Total number of connected components in the graph. There are 3 nodes, true. And there are 2 edges. Yes. And there is return 1 component. Total number of connected components in that graph. So let's look at this. There's 6 nodes here. Right. We have here 0, 1, 1, 2, 2, 3, and 4, 5. So this means there are 2. So like if I follow the trail, do I visit all the nodes? Is that what it's saying? So there's 1 connected component. Okay, that makes sense. That's 1. And then okay. So this is 2 because we can do 0 to 1, 0 to 1, 1 to 2, 2 to 3, and to 1, and it is the 4 to 5 on its own. So this is one little patch, and this is one little patch. Okay, I see. Okay. For this one then, do I want to do I want to enter this edge? Okay, so there's only 1 because this is like I can visit all the nodes. I see. Technically, it's like this. 1 can go to 1. 1 can go to 0. And then 0 can go to... Well, 0 can go to 1 and 2. And then 1 can go to 0, and then 2 can go to 0. Right? This is what the graph really looks like. Right? once it finishes, I guess. Can I restart? It's not like, okay, just because okay, 2 goes to 3, right? Like, just because I start at a different source doesn't mean I count that as a separate one because I can visit everyone else, right? Because, like, okay, if I start from 0, that's considered one thing with one connected components in that graph, right? Because I visit everything. I can't say for 1 and 2, even if I start there and I can't access everyone else. Because I can go to 1, go to 0, go to 2, and boom, we're done. But that's not a second one, right? So I need a different condition to the thing. Like, okay, if I visit all the nodes, is that true? Also, they're numbered. Ah, that's actually kind of useful. They are numbered from 0 to n minus 1, so that's useful. So if we have edges here, we are expecting all these numbers. So if n equals 3, we're expecting to find all these numbers, right? So we'll try to find, well, let's start with 0. How far do we get? We'll start with, we get 1, we obviously discover 0, we'll discover 1, and we'll discover 2. Boom, we're done. That is one component, right? So let's say n is 6, right? We'll discover with 0. How far can we go with 0? That is 0, then we go to 1, then we go to 2, then we go to 3, right? And then that's done, right? That's 1. Then I'll try to go to, these are all the numbers I visited. So I guess I'll skip 1, skip 2, skip 3. Oh, 4. See how far I can go with that. 4, and then go 5. Boom, and that's 2. Right, that's another one. So total equals 2. So yeah, I think having the numbers is fine. So now, what is the traversal do? Should I do BFS on every single edge? Yeah, relatively. I can do a BFS on most edges, I think. Let's just do a BFS. So let's do this. Def BFS. We'll just take a source. Simple as that, right? Then we'll K to Q, DQ, doubly, and doubly like this. I guess we'll have like a global set, right? Scene, right? We don't want to actually reset this because, yeah. So DQ there. Do I reset the set every time? No, I shouldn't. So I guess while Q, cur is equal to Q dot pop left, and then we can do for every cur dot add or scene dot add cur. If cur in scene, return. I guess return false. Well, yeah, whatever. Return true. So we'll iterate through that. Well, I should do this instead. Oops. Right, add that. We'll see that, right? Well, okay, hold on. Okay, it's cur. Okay, cur dot add or scene dot add cur. Then if okay, and then check if cur in scene, then return false. We don't want to process that, so after that, then let's go for neighbor in graph. Oh, I should build a graph first. We'll assume the graph is their graph of cur. Q dot append neighbor, right? That's happening. Okay, now let's build our graph. So graph equals default I guess a list, yeah. And then we'll have for every for UV in edges graph of U dot append V U. We'll have that. For every source in range of n, if BFS of the starting source, then we'll have res equals 0 and res plus equals 1. Return res. Okay. So what does this do? So we are creating a set, right? Or create a scene set, and then we'll start with the queue. Oh, we should start the source here, right? And we'll have this here. So like, what if we have, okay, so for example, 0 will start, so 0 will be put in here. There's something in there, pop it out, so 0 is first. Then is 0 in the scene? No. So that's 0. For every neighbor's in 0, so our neighbors of 0, it looks like this. So when we construct the graph, it's going to look like 0, 1, and 2, right? So let's go through 1 and 2. So let's add 1, add 2, right? So now that resets the queue. 1's next. So 1 is 1 in the scene. Nope, add that. Boom. It's 0 and 1 is in the set, so that's good. Let's check the neighbors of 1. There's no neighbors of 1. Well, actually there is. 1, 0, and 2. And then I guess, okay, yeah. It will add 0, and then 0 will be at the end of the list. Right now the queue is like this. 1, 2, right? Or it's like this. 0, 1. This is the queue. Or actually it's 1, 2, you're right. 1, 2, and then what we have seen so far is this. So now it's just 2, right? And then the Q actually added a 0, so that's gonna be bad actually. Okay, so pop 2, so 2's gone. 2's gone, so we have left 0, and then 2. Process the thing and add 0 again. Right? Add 0 again. So I guess we can do this too. If source in scene continue. We don't need to process them. The only problem though, I assume it's just these are its own little pods, right? So okay, so we add 0. 0 is in, this is the scene, so we'll add 2, right? And 0 is there. For every neighbor in graph cur, q.append neighbor. For every neighbor in graph cur, q.append neighbor. Okay. So okay, yeah. 0, that's gonna return false, and we're not gonna increase. So this is bad, really bad logic. So this kind of messes things up actually. Yeah, actually messes things up. Okay. Maybe I should do for every. Wait, I actually don't know what to do anymore. Okay. So we have this logic here. So basically, I want to traverse until you can't anymore. Basically, right? So I want to go to 0, 1, 2, right? Yeah. Maybe I just don't add it if I've already seen it. So yeah, if neighbor in not in scene, let's just do that instead. Interesting why that works. Oh wow, that works perfect. Okay, that's really nice. Breadth first search. Yeah, nice. Disjoint union set. What the hell? Anyways, alright, thanks for watching guys. I'll see you guys for a while. Peace.